Okay, this is activity 1.1, so it's my 7th grade book. If you guys have your journal books, it starts on page 3 of your journal book. It's just the activity that we're gonna go ahead and do with, that goes along with lesson 1. So this activity works with integers and absolute value, and that goes along with our lesson 1. So to get started, it says velocity has 2 components, which are direction and speed. Direction is the movement of the object either forward, backward, up, or down. So that's the direction. The speed is going to be the numerical value. So numerical means number. So it's the numerical value regarding the direction. It tells how fast an object is moving, but does not include its direction. So key thing to remember is speed does not include the direction. Whether it was going up or down, forward or backward, speed is just telling you how fast something is traveling. So something that you guys are used to is maybe speed from here. If you're traveling from here to Spencer, you might travel at 55 miles per hour. And what you need to realize is the word per can be used. Lots of times a slash mark is used to represent per. Here, miles per hour, mph, is something that is very accustomed to. They're kind of all interchangeable. But I would say this one's probably the most common that you guys will be using. Integers are another set of numbers that we're going to be working with. Integers are a set of whole numbers and their opposites. Whole numbers do include 0, but 0 does not have an opposite. So an example of an integer might be 7, and then its opposite would be -7. So those are integers. It doesn't mean that your guys going to have a set of integers, but when I refer to integers, it might be a positive number, it might be 0, and it might be a negative number. Just so that you know that all of those numbers are included in integers. Okay, so it says what integers could we use to represent the following situations? So we just talked that integers are either zeros, whole numbers, or their opposites. So traveling backward at 10 miles per hour. So here's where we're going to kind of use the wording to help us decide on what integer we want to use. So if it's backwards, well, that's a negative thing if you're traveling backwards in most cases. So backward we're going to represent with a negative, and then the number was 10. So the integer that would represent traveling backwards at 10 miles per hour would be -10 would be our integer. Traveling forward at 55 miles per hour. Well, forward, that's a positive thing. So we're going to do positive 55 was the number that was used. One thing that I do want to point out is integers, when they have a positive, when they're positive, we don't usually put the positive sign in front of them, but in this case, just so that I'm identifying whether it was positive or negative, I will be using that. A parachute traveling down 1,200 feet. So I want you guys to try that one on your own. And then also try letter D, a plane traveling up 1,500 feet. For your sake, if you need a little additional time, you might want to pause the video. I'm going to go ahead and give the answers. So because we were going down 1,200 feet, that would be -1,200. And letter D, a plane traveling up 1,500 feet. Well, that would be a positive because it was up 1,500. And as I said, using that positive sign just for now is just helping me identify that I did state that it was positive and didn't skip over that part of it. Okay, so now we're going to go ahead and jump into your journal book. So this is page 3 of your Big Ideas Math Journal book. It says you're gliding to the ground wearing a parachute. The table shows your height at different times. So here we've got a parachuter, and they are traveling down. So they've jumped out of the plane and they're going down, okay? So we're gonna wanna go ahead and make sure that we have identified the fact that we are traveling down in this situation, okay? So we have our time. At 0 seconds, we were at 45 feet above, so we had jumped out of the airplane. At 1 second after jumping out of the airplane, we are now at 30 feet above ground. At 2 seconds, we were at 15 feet above ground. And at 3 seconds, we were now at 0 feet above ground, or we had touched the ground. So it says, how many feet do you move each second? So in order to answer letter A, we have to kind of look at the change in our feet. Right now, the change in time, yes, we notice that the change in time is every second, but we have to identify how many feet it changes. So if we look here, it went from 45 to 30. Well, that's a change of 15. 30 to 15, once again, was a change of 15. And if you don't understand how to do that, you're just going to go ahead and subtract between those to figure out the difference between them. 15 to 0 was a change of 15. So we noticed that on every single situation, it changed 15 feet in every second. What is your speed? So remember, speed includes your unit of measure and your time. So miles per hour. In this case, we're not working with miles, we're working with feet, and our time was seconds. So we just identified that it changed 15 feet per, so I'm going to use the slash mark, and then our time unit was second. So 15 feet per second was our speed. Is your velocity positive or negative? So that's once again where we're going to go ahead and use this concept of that arrow. And I know I kind of colored over the arrow and it looks horrible, but it's still a downward arrow. So would that be a positive or a negative thing? Well, going down is negative. Letter D says, what is your velocity? Give the units. And I did kind of put in red writing here just so that you understood the difference between C and D. That velocity, they want you to include the direction and the speed. So really we're putting answers B and C together. So our answer to B was 15 feet per second. And we identified that it was in a negative direction. So I'm just going to put a negative sign out in front of it. So our final answer for D is negative 15 feet per second. Okay, I'm going to go ahead and erase this and put this stuff off to the side. And I'm going to go ahead and put example 2 out here. There is a third one on the next page that you can do independently. And if you need the answers, you can contact me. So for number 2, it's raising balloons. So don't forget to identify your direction. You're going to go ahead and do the same concepts that we just did on the previous activity. So they want to know how many feet it changes each second, what is its speed, whether the velocity was positive or negative, and then to give the velocity. And remember that for letter D, you're including the speed and whether it was positive or negative. So go ahead and pause the video for the time that you need to answer A through D, and then turn it back on so that you can check your answers. Okay, so for our answers for letter A, it says how many feet do the balloons move each second? Well, I can identify from up here that it changed 4 feet. What is the speed of the balloon? So speed is including the unit of measure as well as the time. So the unit, well, it was still 4 feet. And then per, the amount of time was second. Is the velocity positive or negative? So that's where I'm going to use my arrow. So it was going up, so that would be a positive velocity. And letter D, what is the velocity? Give the unit. So that's where we're going to put B and C together to answer that. So our answer to B was it was 4 feet per second. And then I am, even though it was positive, I'm going to go ahead and put that positive sign in front of there just to identify that I did do all the steps and that it was a positive velocity. Okay, you may go ahead and work on activity 3 on your own. Try that out, get back together with me to check your answers for a little independent practice. We're going to go ahead and jump then to page 4, which was working with inductive reasoning. And in that, you guys have this chart already in your book, so you don't have to copy and complete the table. It's already there. So velocity and speed. So it tells us the velocity is negative 14 and they want to know the speed. So really quick, I'm going to jump back to something back here. Remember, velocity includes the direction, that positive or negative. And speed, on the other hand, did not. So that's kind of my hint to you as we're going through and working our way through this table, is velocity is going to include the direction, whether it was positive or negative, forward or backward, but we use the positive and the negative signs, and speed is not going to include that. So if we were going backwards 14 feet per second, well, our speed would still be 14 feet per second. Okay, the second one, that's a positive 20. They did not include a positive sign. It's just inferred that that means that it's positive. So we were going up or forward or whatever for 20 feet per second. Well, our speed was still 20 feet per second. And in the third one, -2, well, that could be we moved backwards 2 feet per second, or we went down 2 feet per second. So what was our speed? It was 2 feet per second. So our answer there would be 2. Why don't you go ahead and go through and do the last three of 0, 25, and -15 and figure out the speed of each of those. If you're struggling, kind of look back at your first three answers and compare that speed to velocity. Most of you are probably going to make that connection right away. If you need extra time, go ahead and pause the video. Our answers for our speed of 0 would be 0 for the speed, 25 feet per second for the velocity. The speed is also 25 feet per second. And negative, which would either be down or backwards, 15 feet per second, would still be a change of 15 feet per second. So take note that all of our answers in this column ended up with positive answers. Speed does not include the direction. Number 5 says find two different velocities for which the speed is 16 feet per second. So remember, velocity includes direction. So we could be going up 16 feet per second. And you don't have to have the positive sign, but I'm going to include it. What other direction could we be traveling at 16 feet per second? We could be traveling down or backwards, which is a negative 16 feet per second. Okay. Number 6 says which number is greater, -4 or +3. Use a number line to explain your reasoning. So I'm going to go ahead and draw a number line. Now you guys have a number line in your journal book, so this kind of saves you time. Forgive my handwriting. I'll try the best I can. And I'm going to review really quick how to set up a number line. You have 0 that's sitting in the middle. And then working your way out from 0, it goes in the same order. So my first tally mark here would be +1. There's my 0. Sorry, I forgot to put that in there. On the other side of the 0, that would be its opposite, which is -1. So over here I would have 2. And on this side I would have -2, its opposite. 3 and -3. 4 and -4. So there's our set of integers. I could go as far as I needed to, but just for the sake of this question, we only needed to see -4 and all the way out to +3. So I'm going to stop with those numbers. So it says which number is greater, -4 or +3. So I'm going to use a different color marker, and I'm going to mark where each of those is on the number line. So here's my -4. It's pretty easy to identify. And here's my +3. Now, many students at your level will be able to do this without the number line, but I go ahead and break it down in case I have some kids. Negative numbers they're confusing when you're working with positives and negatives. So sometimes just having that visual until you get comfortable will help you get through that I don't get it stage. So here, now if I look at this, although the number 4 on this negative in your head is a bigger digit, you have to remember that when you're comparing positive and negative numbers, any number that is furthest to the right on the number line is worth more. So in this case, -4 is clear down at the left-hand side of my line. +3 is clear to the right. So +3 is going to be my answer for which is greater between -3 between -4 and +3. Okay, and as we get into comparing like two negative numbers, everybody's good with positive numbers because you've worked with positive numbers since you were in elementary school. As we get into working, we're maybe just working with just comparing two negative numbers. Well, some of you might have to rely back on the number line, and some of you will get comfortable with just understanding that the larger the digit, the less it is worth, because remember, that negative sign is its opposite. So you kind of have to think opposite in those terms. Number 7 says one object has a velocity of -4 feet. Another object has a velocity of 3 feet per second. Which object has a greater speed? So in order to do this, guys, remember this is talking velocity. So it's giving us the direction. We just want the speed. So we're going to have to go through and kind of do what we did up here in our little table. We're going to find the speed of each of those. So -4 feet per second has a speed, and I'm sorry for writing over this, but and then I spell it speed. So -4 really has a speed of 4 feet per second. We just aren't identifying that it was down 4 feet or whatever. 3 feet per second, so +3 feet, is still going to have a speed of 3 feet per second. So now if we compare that, it says which object has a greater speed. So if we are now just comparing these two numbers, which are our speed numbers, we identify right now that really the answer would be the -4. It doesn't matter that it was dropping 4 feet per second. It was still traveling 4 feet per second, which is faster than 3 feet per second. So remember, speed does not include the direction. Okay, so once again, things that we've kind of gone over in this lesson, we've been working or will be working more with absolute value, and this activity that I had you do was just kind of giving you an understanding of some absolute value, but here's kind of a visual. The absolute value of -16 is 16. The absolute value of a +16 is 16. So the most common made mistake is kids always think that absolute value means opposite. And absolute value bars actually look like this, and we'll go over that some more in our next lesson, but then you would have a number inside of here. Okay, so like -16, that's what this right here is referring to. It would look like that if we were using the symbols. And take note that both of these answers had the same answer of 16 because absolute value is just kind of like the speed. It's how far it is from zero. It's absolutely how far from zero, how many places. Absolute value of 0 is 0. It didn't go anywhere. And the absolute value of -2 is 2. So it doesn't always mean the opposite. I know in these two situations, we ended up with an opposite answer, but absolute value is not opposite. It's how far it is from 0, or to refer back to the activity that we just did, it was the speed that it was, okay? In your own words, how are velocity and speed related? So how can we give a relationship between those? Well, remember, speed is going to tell like how fast something is. And I'm not going to write this down on the board. I'm just going to go over it verbally. Speed is going to tell you how fast. Velocity is going to include that direction of the positive or the negative. Okay, and that's how they're related. They both will have that numerical value and that label of miles per hour or whatever. But the velocity is going to include that direction of whether it was a positive or a negative direction. Number 9 says, which of the following is a true statement? Explain your reasoning. So these are kind of confusing to me. I'm a very visual person, so I tend to need those visuals to help me understand what they're talking about here. So letter A says, absolute value of velocity is equal to the speed. So absolute value, remember that's this symbol up here. So the absolute value of velocity is equal to the speed. So I'm going to jump back to my previous slide because that's going to help me maybe with the visual. So the absolute value, so I'm going to use that symbol, of velocity. So remember, this is my velocity right here. This is my velocity column. equals the speed. So if I gave the absolute value of negative 14, did that give me the answer of the speed of 14? Yes, it did. The absolute value of 20, absolutely, how far is 20 from 0? It's 20 places. Yes, it did give me, they were equal. The absolute value of negative 2, well, that would be 2 places away from 0. Is that the answer I got? Yes. So in this case, and I know this is kind of leading into our lesson, this would be a true statement. The absolute value of speed is equal to velocity. So that's kind of doing the opposite. So I'm going to jump back again and use my last 3 there. So the absolute value of speed gives me the velocity. Okay, well, the absolute value of 0 would be 0. So in that case, yes, it worked here. But for us to say, yes, that's true, it has to work in every situation. The absolute value of 25 is 25. Yes, that worked. Oh, for some reason my thing is jumping. That was a yes, not a funky little thing. The absolute value of 15 should be 15. Whoops, we're off right there. We got a negative 15. This would be a no. So in other words, we're going to have to say that that is a no statement or a false statement. Okay, that concludes our activity for lesson 1. If you have any questions, please contact me. You can come see me during class, before or after school, or you can email me if you have a question and you're at home. I can't guarantee that I'll get to it right away that night, but I will get back to you the next day. Thank you.